This is Miss Wiles, and in this video we'll be talking about the quadratic formula and using the quadratic formula to solve quadratic equations. We can use those solutions to find the factors, and we'll also talk about a part of the quadratic formula called the discriminant and what that discriminant tells us. So what you see on the screen now is the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there are songs out there about that, and you can find the little videos with the song about the quadratic formula. You can Google the song, the quadratic formula song. And just the other night, my daughter, who is terrible in math, believe it or not, and who is 21 years old now, and who graduated from this school several years ago, she still knew the quadratic formula song. Now, whether she knew how to use it or not, I don't know. But she knew that song, so if you want to memorize a formula, sometimes a song is a way to go. The quadratic formula is very useful if the format of your quadratic equation is in ax squared plus bx plus c equals 0. If that's what your quadratic equation looks like, if it's in standard form, then you can identify the a, the b, and the c, and you can use the quadratic formula to solve the equation. So we're going to do a few examples. Now here's an example of a quadratic formula. G squared plus 2g plus 1 equals 0. And it is in the format of ax squared plus bx plus c. And it could say equals 0 or equals y or equals f of x or anything else, but everything in the quadratic formula is together on one side of the equal sign, on one side of the equation, and it looks like it's in standard form. So what we do first is identify what is a. We look at the coefficient of g squared, and a is 1. Here's that 1 that you can't see. B is 2, and c is 1. Now, can those numbers be negative? Of course they can. Can those numbers be 0? B and c can, but a cannot be 0. So those are little things that you might not catch when I say them the first time in class, but if you rewatch the video, you might catch those things and add them into your notes. That A will never equal 0, B could equal 0, and C could equal 0. Can they be fractions? Sure, they can be fractions. Can they be negative? Definitely, and pay attention to that. Well, once you identify what A, B, and C are, then you can plug it into the formula. That whole substitution thing where you're just plugging it into the formula. And that's what you see here. You see those values plugged into the formula. Negative b, since b is 2, negative b is negative 2. Then plus or minus the square root of b squared, which is 2 squared, minus 4. That 4 stays the same all the time. A in this one is 1, c is 1, and then put all of that over 2 times a, which in this case is 1. Well, what's over here under the magical box is what I would put in my calculator. If I'm doing this problem, I'm going to use my calculator. And there it is. What you'll do is you put the first one. I always put the plus, you know, where this plus or minus is right here. I always put plus first because we are creatures of habit. And if we do the same thing over and over and over again, it's almost like muscle memory. We just do it that way every time. So I put negative 2 plus, put all of that in the calculator using the fraction key and everything else, and it looks all nice and neat, and it comes out with negative 1. And then, because I'm a lazy person, I just want to cut down on the labor. I'm not really lazy. I went up with an arrow and highlighted that and copied it and changed that plus to a minus and did it again. Now, in this instance, it just so happens that both answers are the same, but that will not always happen, and you'll see that on the second example. So this is a method that will work very well when your solutions are going to be integers or fractions, And if you recall from some other videos and other work that we've done, we can take those solutions and we can find our factors. If our solutions, I call them solutions because there's usually two, but even if our solutions are just one number, if our solution is -1, that means our factors are x plus 1 squared, because we have to do that twice because this is a quadratic formula. So if we're going from our solutions, if we only have one unique solution, then our factors look like this nice little x plus 1 squared. It starts off looking like x plus 1 times x plus 1, because there's always two solutions to a quadratic equation, but when both binomials are exactly the same, that becomes that one binomial squared. All right, here we go. Let's go to another example. Now, in this example that I've written up here, our quadratic equation is in the right form. Now, when we look at this quadratic equation, in every quadratic equation, there is a value for A, there's a value for B, and there's a value for C. In this particular quadratic equation, A is 5. In this particular quadratic equation, C is 30. In this particular quadratic equation, since there is no x, b is 0. So let's pause here, take a couple minutes to put this in our calculator using the quadratic formula to find our solutions that way. But before we pause, let's write what we're going to put in our calculator. Because I like to do that so that I can look at what I know I want to have in the calculator and compare it to what I have in the calculator. So using the quadratic formula, -b plus or minus the square root of b squared minus 4ac, all of that over 2a. Let's pause here while you put that in your calculator. In the magical time of the pause button, we change that a to a 5. Now we've got this in our calculator, and we press enter. And we get an error. And the error actually has some words there beside it. It says non-real answer. What that tells me is that the answer to this problem is an imaginary solution. That this problem has an imaginary solution. So I'm not going to quit, because I never quit. I'm going to go to. So I can see what it is about this problem that makes it have an error. And that works all the time, by the way. In this one, if I know enough about the quadratic formula and I know when I'm going to have imaginary solutions, that is going to happen when this value under the radical sign is less than 0. And if I were to take this part out and do 0 squared minus 4 times 5 times 30, well, that's -600. And -600 is definitely negative, and it's under a radical sign, so I should know that my answer is going to have an I in it somewhere. Well, unless my calculator knows that I should be in imaginary mode, it doesn't know what to do with this. So if that happens, and don't ask me why the calculator doesn't just default to imaginary mode, because I didn't program it. Go into mode, go down to where you see the word real, go to the right of it and choose A plus BI. Press enter so that you will be in imaginary mode. Go back to the problem. Press enter again. And you still get a data type error. Now, I had actually forgotten, before I hit that enter again, that I was going to get another error. I forgot that in imaginary mode, for whatever reason, this calculator will not deal with this fraction. It won't. Now, I can change it so that I put this in the calculator with parentheses and stuff, but that ends up taking too much time. At this point, you may just want to break out and do it by pieces. So I could put in, I'm going to pause and put what I would put in the calculator this time. Okay, so while we were paused, we went in and we put the division in the calculator using the parentheses and the division sign and everything else. When we bring that calculator back up so that we can see, it's only going to give us a decimal answer. It gives us this 2.449, blah, 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 and then we see an I on the end of it. Now, if that could be changed into a fraction, it would do it for us. We could just change it to a fraction. But if it won't be changed to a fraction and our exact answer is really plus or minus I square root of 6, the calculator will only get so close. So it's helpful if this was a multiple choice answer, but not as helpful when it is a radical answer. If you have to give an exact radical answer, it's not as helpful. Except for you can use the calculator to do this. You can use the calculator to work it out piece by piece, but at that point, it's almost better to go back to method 2 that we talked about. And if you have an equation like this, if you see this, you already know that you don't want to use your calculator. That's what it would teach me about this, is that if I see this and I want an exact answer, I don't want to use my calculator. I want to go and I want to solve it using method 2, where I have the 5x plus 30. And because I see that it's this type of equation, then I'm going to move the 30 to the other side. I'm going to divide by 5. I'm going to take the square root. And then I have my answers. To me, that is a lot faster than trying to use the calculator over and over and over again. That's why a lot of times students will get all crazy and in an uproar, like, why are you showing me so many different ways to solve an equation? And it's because depending on what the equation looks like, your choices make your work easier or harder. So if you see an equation like this, you should say, I'm not going to use the quadratic formula. I'm going to use the square root method. And that's why there's different methods, so that you can choose the best method. Now, if your answers are going to be real numbers and things, quadratic formula, you can do that all the way. All right, here we go. Another example. We're not going to do both of these in this block, but go ahead and do the first one. In the video, what you're going to hear me explain is the first one. You won't hear me explain the second one, but then you'll see the answer come up for the second one. With number 1, or with the first one that we're going to do, what is A?
5.
What is B?
4.
Nope. -4. That is very important. What is C?
-1.
-1. Those minuses are extremely important, because if you don't get those pluses and minuses right and know whether it's really positive or negative, then you're going to get a false answer. Now pause and use the quadratic formula to find your answers. Okay, so here, while we were paused, we talked about why -4, if I were to put -4 squared here, it's going to have to be -4 in parentheses squared, because the formula says take B and square it. If I were to just put this in the calculator, I get an incorrect answer, but I don't even know it's incorrect unless I catch my mistake. So I've got to make sure. Now, there's a workaround if you realize that -4 squared equals 16 and 4 squared equals 16. So it doesn't matter if I make this negative or not, as long as I know what I'm doing. So whatever it is that works for you, that is how you use the quadratic formula. If you're studying this at home and in class, certainly when you use a calculator, it's not like you can copy your calculator screen onto your paper. But if you go into the video and pause and look, you can compare what you're doing. Let's look at another example. And again, later on, even if you're not once you see this posted to Google Classroom, you're going to see the answer for this second problem over here too, so that you can practice before you get into IXL if you want. So here's the next screen. On the next screen, we have 2 problems. You're going to do one of them in this class. So which one do you want to do? Number 1?
Yes.
Okay. What is A? And B?
9.
And C?
6.
All right. Use your calculator and find your answers. If you're rounding to the nearest hundredth here, this would be negative 0.81, and this would be negative 3.69. Let's go back to this screen. If you're watching at home, this would be a good time to come back and try to do this problem. Or if you're watching it in class later on, you would pause here, you would try to do that and come back in. Now that you're back in, there's the answer to that one. Let's go forward to this one. Do the same thing. Work this one out. Pause. And now you can check your answer here. Not like that, though. Notice that when this changed, the only thing that changed was the negative 9. So I just did some copy-paste. And notice that the answers there are just the opposite of what you got on the other side. Okay, let's go forward and work out one of these. Which one do y'all want to work out? The second one? All right, we'll pause here. And there are your answers. And S is kind of arbitrary here because we have one solution, and that solution is negative 2. But if you're looking for two solutions, they're called like they're multiplicity factors because they are exactly the same. They're not two unique solutions. It's two solutions, but they're both the same. Just to make everybody happy. Try doing the 5p squared plus 8p plus 3 if you need more practice at home or some other class. And I will say pause, and then after I say pause, I will reveal the answer so that you will have paused and tried it. Pause. Now, I want you to keep in mind, since you're back in, that again, if I were doing my factors here, my factors on this one would be x plus 2 squared. And my factors over here would be 5x plus 3 and x minus 1, or p, whatever variable you want to use. And there are two more examples that you can work on if you need to practice before you get into a skill where it really, really matters that you have the right answer as much. And there are the solutions for that. And again, for the purposes of this particular skill, decimals are going to be okay. Just round to the 100th. Now I want to talk to you about that discriminant, that b squared minus 4ac. That b squared minus 4ac is called the discriminant. It's what's under the radical sign. If you extract just that part of it, and you check to see what b squared minus 4ac actually equals, if that number is less than 0 or negative, then that means that you are going to have two imaginary solutions, two complex, non-real imaginary solutions. If that value of b squared minus 4ac is equal to 0, you have one real solution. And if that value is greater than 0, which is also the same as positive, then that means you will have two real solutions. That is all the discriminant really tells you, but you could be asked, based on the discriminant, what types of solutions would I expect? Now, can you use it? Can you use the whole quadratic formula? Go ahead and use it. Find your two answers, or at least find the error that you used that you might see in the calculator to make that determination. Yes, you can. So however you discover what types of solutions you have, you can tell by the discriminant. So we're going to use that discriminant to do a couple of problems. Okay, so we can use that. Oh, and during pause, we kind of talked about how we can take notes a lot faster than copying everything. So find the discriminant. And what does that discriminant tell you about what type of solutions the equation could have? Now again, you can just work out the solutions if you want to, And sometimes you get good enough that you can even tell just by looking and comparing the numbers and things like that. But that's for you to figure out. So the discriminant will tell you what type of solutions you have. You would, again, still need to identify your B, your A, and your C, and find your discriminant and determine what you have. Let's pause here while you do that. If you're checking this with just the discriminant, your discriminant equals 21, which tells you that you have two real solutions. It doesn't tell you what they are, and 21 is definitely not your solution. But if you went back to the quadratic formula and you were looking for an exact answer, that negative b plus or minus the square root of 21 now, all over 2a. But that's for another video. We don't have to do that right now. Going on to the next problem. Find the discriminant and determine what type of solutions you have. The answer for the discriminant is 0. B squared minus 4ac equals 0. If b squared minus 4ac equals 0, that tells you that you have one real solution. Again, it doesn't tell you what that solution is, but it tells you that you have one real solution. So it'll just be the same. If you were to do the quadratic formula twice, you would end up with the same exact answer both times. And another. Find the discriminant and determine what type of solutions does that tell you that this equation will have. Okay, here we go. Our discriminant is 177. Now, I got that because and you would get it anyway. Negative 9 squared. Did I do it right? I saw some of y'all get a negative number. Minus 4.
I got negative 15. I got negative 15. I got 177.
If you got negative 15, then your answer would be that you would have two complex non-real solutions. I think that what happened if you got negative 15 is that you put...
We didn't put negative 3 in.
Yeah. Oh, you didn't put negative 3?
Oh,
okay.
No.
The other thing that could change your answer, you got to make sure that this is negative 3 from this negative minus 3. The other thing that could change your answer and give you a false answer is if here you put negative 9 squared without parentheses, that would mess it up too. So you got to make sure that everything's put in just right, just like you do with everything else. And here we would have two real solutions. Okay, next, let's try this one. Don't forget your negative signs. If they matter, don't forget what you're looking at. Find the discriminant. What type of solutions does the equation have? And our answer is negative 19. Because again, 3 squared is the same as negative 3 squared. Either way, you get negative 19 and you have two complex non-real solutions. One more example, just for good measure, and then I think that's all we have to say about that. I'm going to give you this. Okay, I'm back in. Here we go.
I got negative 17.
If you got negative 17, you must have done something wrong. Maybe you put in negative 9 squared.
Isn't it a negative 9?
It is, but you got to put parentheses around it if you're going to put in negative 9.